You see the headlines all the time, right? Tesla, SpaceX, X. But what if they're not really separate companies? What if they're all just visible pieces of a much, much bigger, interconnected master plan? Okay, let's peel back the curtain on this. Because when you start connecting these dots, a truly mind-bending picture of the future starts to take shape.
So let's start with something we all think we know, Starlink. It's that satellite internet thing, right? Gets you online in the middle of nowhere? And yeah, it is. But it turns out, just providing internet to the whole world might be the cover story for a much, much more ambitious endgame.
And what is that endgame? Well, it's turning the sky, the literal sky above all of our heads, into a single planet-sized supercomputer.
Now, this isn't just some wild theory. A researcher over in Korea recently dug up a SpaceX patent. And it wasn't for a new rocket engine or a fancier antenna. Nope. It was a detailed blueprint for a distributed satellite network computer. The entire plan was basically hiding in plain sight.
Okay, so what does that actually mean in plain English? Well, imagine instead of building a giant data center on the ground, you could link thousands and thousands of smaller computers, in this case the Starlink satellites themselves, so they act as one enormous, cohesive brain that's orbiting the Earth. That's the idea.
And just in case you think this is some old patent that they filed and forgot about, think again. Elon Musk himself confirmed it not too long ago. When someone asked him about putting data centers in space, he didn't hesitate. He just said, yes, SpaceX will be doing this. The plan is very much alive.
So, we've got the blueprint and we've got the confirmation. But it's the sheer scale of this operation that takes it from just a cool idea to something that could literally change the world.
This right here is the key question. Starlink already has about 10,000 satellites up there, which is more than enough to give the entire planet internet coverage. So, why on earth have they filed the paperwork to launch a total of 40,000 satellites? The answer is pretty simple. You don't need 40,000 for internet, but you do if you're building a global computer.
And they are not waiting around. The pace they're moving at is just staggering. This year alone, SpaceX has already put over 2,000 new satellites into orbit. And to really understand how wild that number is, you have to see it in context. Those 2,000 plus satellites they've launched so far this year, that is more than every other country and every other company combined has launched in the entire history of spaceflight. Just let that sink in for a second. They are building this thing at a speed nobody else can even begin to imagine.
And this is the truly brilliant part of the strategy. It's not like they have to start building this computer from scratch. The satellites they're launching right now, today, already have the laser interconnects built right in. That's the tech that lets them all talk to each other and act as one single unit. The hardware is already being deployed with every single launch.
But look, this planet-sized computer in the sky is just one piece of the puzzle. This same kind of long-term, integrated thinking isn't just for space. It's aimed squarely at changing some fundamental things about how we live right here on Earth. The space data center is a massive piece, for sure. But when you look at how they're approaching things like transportation and even the phone in your pocket, you see the exact same pattern. Figure out the real, fundamental problem and then build a solution that just sidesteps it completely.
Think about flying cars. For decades, everyone's been saying the big problem is the battery. We just can't get enough power. But what if that's the wrong question entirely? What if the real bottleneck, the thing that's really stopping them, is the fact that you need all new infrastructure, like special airports and landing pads in every city?
The solution being worked on completely flips the script. Instead, you build a vehicle that's a car first. You drive it on normal roads and normal traffic, but when you need to go to the next city, you take off and fly there, point to point. When you arrive, you just land and keep driving.
And that's the absolute genius of it. With this kind of design, you don't need new rules, you don't need new laws, you don't need to spend billions on new infrastructure. You use what's already there. It makes the idea practical from day one, while everyone else building drone-like taxis that need special facilities are, well, basically dead on arrival.
This same way of thinking applies to the device we all have in our pockets. See, when asked if he would ever make a phone to compete with Apple or Google, Musk's answer pretty much suggested he's not interested in playing the current game. He's thinking about what comes after the game.
He sees a future that doesn't even have apps. A device where you don't scroll and tap on little icons. You just speak your intent to a really powerful AI. It computes, it connects instantly to that giant brain in the sky, that data center we were just talking about, and it just gives you the result. The screen basically becomes a simple display for the AI. So you have a data center in the sky, a flying car that doesn't need an airport, a phone with no apps. What's the thread that connects all of these incredibly ambitious projects? Well, the answer seems to be a unique way of thinking and a really rare combination of skills.
According to his own top engineers, what makes all this possible is having a deep, almost instinctual understanding across a bunch of different fields all at once. Software, AI, manufacturing, physics. It's that ability to see how all these pieces fit together that lets you build these huge system-level products.
And this is the absolute key to the whole thing. Instead of looking at what the competition is doing and trying to be, say, 10% better, this approach looks at the fundamental laws of physics. It sets the benchmark at the absolute theoretical limit of what's possible, and then it works backward from there.
Here's a perfect example of what that looks like. When he's asked about making AI more efficient, his benchmark isn't another company's computer chip, it's the human brain. Your brain does incredible computation using only about 10 watts of power. So he says that's the proof that it's physically possible, and that's the target they're aiming for.
So when you put all of these pieces together, it starts to look a lot less like a series of random ambitious bets. It feels much more like a grand strategy. It feels like the end state, the final goal, is already mapped out. And what we're all watching with every launch and every new product is just the pieces being put on the board one by one.
And remember, all of this is just based on the patents we can find and the plans that have been talked about publicly. It really makes you wonder, doesn't it? If this is the breathtaking scope of the parts we can see, what parts of the master plan are still waiting in the shadows?